The last part of the lecture on strength of evidence relates to publication bias. So far we discussed that a study only provides a noisy signal, a signal of whether the treatment works or not, for instance. Now we are going to discuss that this signal may actually also be biased. What is publication bias? Well, the term bias is something familiar to you from Econometrics 1, for instance, and it relates to non-random selection into treatment so far. That's the context that we discussed so far, and this is actually not so different, because the idea is that not all studies are published, as in the causal diagram, but there is a selection process. For instance, only studies providing statistical significance, so only studies with a positive result, are published. That is the so-called file drawer problem. And on top of that, there's also the so-called p-hacking problem, that researchers may not report all of their findings. So they may not submit a paper that does not provide a statistically significant result, or they may only report certain results. For instance, they look at many interaction terms, and then they only report those interaction terms that provided statistically significant results. As a researcher, you actually have many more degrees of freedom when you are conducting your research and when you did not pre-register your study. For instance, you may have a choice between several outcome variables, and certain outcome variables may show better results, or even if you have one outcome variable, you may define it differently. You may either put it into a 0-1 format, or you may take the natural logarithm, and then we get to functional form actually. When estimating your model, you may or may not include certain covariates, etc. So in the process of going from empirical work to publication happens a lot, because authors pre-select findings for publication, and also reviewers and editors affect what gets published and what does not get published. So you should always be aware of the fact that whatever you report, for instance, in your master thesis, if you say, well, I've got a p-value of 0.04, well, yes, but that is all conditional on the specific functional form that you chose, the specific model, i.e. What kind of covariates did you choose, for instance, and this is all assuming that there is no effect. Then you may find this p-value, but this p-value may well be different if you choose a different functional form, for instance. And that's also the way that your supervisor and your second reader should look at your results. And so that means that it's totally fine to report a statistically insignificant finding, and I should warn you that there is a good chance that you do find a statistically insignificant finding, because the studies that you read are not representative of the empirical work that is being conducted because of this publication bias. What you do not see is those many studies that did not get published, or those alternative model specifications that were left out. Right? So if you do your own study, there's a good chance that you do not find a statistically significant result. Now, when we are thinking about strength of evidence, then you feel this coming, that strength of evidence being posterior over prior. If there is bias, then the strength of evidence is likely to go down, and I'll explain you exactly how that happens. But let's first define publication bias more specifically. So what kind of publication bias are we looking at? Well, let's follow Ioannidis, and the share of statistically insignificant findings that end up reporting being statistically significant findings, right? So that is the idea. I.e., when you see a study, so for example, you get out of this program and you are an advisor to a policymaker or to your boss in the company, then if you see a statistically significant result in a study, then you should be a little skeptical, right? So, one, what did the authors not report? Two, what about all of those studies that were not published? And we can actually put the same framework to work again, and how this works is as follows. And so on the top we have the familiar table, and then there's no publication bias. So then you can work this out. That is the usual entries in a table with false positives and false negatives. But if there is publication bias, then there's going to be a shift from test minus, so negative results, so statistically insignificant results, to test plus, so positive results, statistically significant results. And that is, there's a shift by U. So U is basically the share of negative studies that are reported as positive. Now here's a numerical example with power, priors, and alpha chosen such that it is fairly typical for an economics journal. So basically with a power of 30%, alpha of 0.05, a fairly skeptical prior of 0.2, but first no publication bias. If we then compute the posterior, then we get 0.60. So the base factor is then 0.60 over 0.2 is 3. If you report a statistically significant finding, then we don't learn too much. So your prior goes up from 0.2 to 0.6, which is not nothing, but this not being a very strong design, giving the low power, the base factor is still pretty low. Let's now see what happens if you do have publication bias. Then there's going to be a shift from statistically insignificant findings to significant findings. Now this shift is most pronounced for the studies that are conducted for treatments that do not work, because the bulk of the studies are in a category the treatment doesn't work and I do not find evidence of an effect. If 20% of those studies are actually biased, then there's going to be a large number, like almost 1,600 going up in that other category that are now reported as statistically significant. And obviously 20% of 1,120 is much smaller than 20% of 6,080. So there's only a small shift in the studies that are conducted when the treatment does work. Now, if we then compute the posterior, and then you can do this at home, then you'll find that the posterior is pretty much the same as the prior, i.e. we didn't learn anything. And so we might as well not conduct a study because we don't learn much, because our prior remains almost the same. So what does that mean? So Ioannidis basically says that there's not too much that we can learn from most studies in economics literature. On top of this, there's a good chance that if you are selecting some studies for your literature review, for instance, for your thesis, or later on when you're doing your work and your boss or some policymaker wants to know something about a certain topic, then the studies that are most easy to find are the most newsworthy publications, because that's just the publications that get a lot of airplay. They're covered in magazines and all that. The trouble is that there is an additional selection filter that implies that the most newsworthy publications tend to also be the least trustworthy, because editors tend to select studies based on newsworthiness and trustworthiness. That's the famous collider again. They both affect whether a study is selected in one of those top journals, and as a result, so within that selection of studies published in top journals, we find that there is a negative relationship between newsworthiness and trustworthiness. Alright, there's a link between publication bias and replication, namely that given all the p-hacking that is going on, consciously or maybe not consciously, it may be that sort of researchers believe that the findings should be such and such, so they select a certain functional form and they select a certain outcome variable, etc. But if you try to replicate such a study, then and you do not have those 100 degrees of freedom, then it's very unlikely that you are able to also find a statistically significant result, right? So say that you see a study reporting that a certain treatment works wonderfully, and then you're like, well, I have similar data, or I may have data in another context, in another country, and I replicate it, and I do not find a statistically significant result. And I really do the same thing as the authors, but given all the forking path that authors follows, it's very likely that when you do not have all those degrees of freedom, that you end up with a statistically insignificant result. Alright, so that's it, and here's a list of things that you can actually check at home to see whether you learned what you learned this week and whether you absorbed all of the material.